Today we're going to talk about translations of quadratics, okay? Quadratics include a parabola. This is a parabola. It's a graph that's in the shape of a U. So to talk about translating quadratics, we first have to understand that this, in this case, for the problem that we're going to do today, this would be what's called the parent function. So in this instance, the parent function would be x squared. And because it's squared, that's what's making this U shape, okay? That's a positive parabola because it's facing upwards, okay? So what we're going to do today is we're going to go over what change is going to happen to this parent function. What does that change make it do verbally and in an equation? And then how does it change looking on a graph, okay? So we're going to take our first problem. Here's our parent function. So the first thing we're going to do is we are going to change it a little bit. So, Annabella, give me a number, a small number to be added.
6.
Smaller.
4.
Okay, fine. 4. Okay. So, if I notice I had x squared, and now I'm putting the x in parentheses, and I'm adding 4. So the change that's happening is I'm adding inside the parentheses. What that change is going to do is if I'm adding inside the parentheses, adding inside the parentheses means to move to the left. So according to here, I'm going to move to the left 4 times. So all our graph does is it's going to take our first, this right here is our vertex, also known as the minimum. And we're going to move it 4 times to the left. So 1, 2, 3, 4. I'm going to go find another point. There's a point at 1, 1 and negative 1, 1. So I'm going to count 1, 2, 3, 4. And 1, 2, 3, 4. Obviously, I'm not going to have enough room, so we're just going to kind of pretend that it's perfect, and we're going to draw it. So there we go. We moved our parabola 4, and the only way that you did it was we took our parent function and we added 4 on the inside. That was it. So now we're going to do another one. Now we're going to change our parent function. But this time, instead of adding, I'm going to subtract inside the parentheses. Annabella, I need a teeny tiny number.
2.
2, okay? So we're now going to subtract on the inside of the parentheses. So when I subtract on the parentheses, it's going to change. So when I subtract inside the parentheses, now I'm going to be moving to the right. So every time you see subtraction inside the parentheses for a quadratic like this, the graph will be moving to the right. And in this case, we're moving to the right 2. So normally when we think positive, we think to the right, negative, we think to the left, which is almost always the case. However, inside quadratic parentheses, we're going to do the opposite. So right now, if our point is at 0, 0, and it's telling me right here to move to the right 2, I'm going to literally move it to the right 2. 1, 2. I'm going to take this point and move it to the right 2. 1, 2. I'm going to take this point and move it to the right. 1, 2. Take this point, 1, 2. Take this point, 1, 2. And then I'm going to draw my new parabola. There we go. So again, if I'm changing the inside of the parentheses, I will be moving to the right or the left. If I'm adding, I move to the left. If I'm subtracting, I move to the right. All right? So now we're going to try it when we add something on the outside. So now we have our parent function, which is still that x squared, f of x squared. But this time, I'm going to add something outside. Annabella, I need a number between 1 and 4.
2.
Okay, so Annabella wants to add 2 on the outside. So if I look, I have parentheses, but this time I'm going to add outside the parentheses. So what that means for us is when I'm adding outside the parentheses, I'm actually going to be moving up. So our graph will be moving up. So in this case, we will be moving up 2. So we go to our graph, we draw our first vertex point, and we literally move it up 2. 1, 2. We take our point here at 1, 1 and move it up 2. 1, 2. We take our point here at negative 1, 1 and move it up 2. 1, 2. Same thing with all of our other points. Because we don't have much room, we're just going to go ahead and graph our parabola. So as you can tell, the parabola stays the same size. It's just being translated up 2. And it's called a shift of up 2. Alright, so now we're going to try another one. Again, we have our parent function. X squared. Annabella, I need a negative number between 0 and negative 4.
3.
Negative 3. Okay, so now we're going to have x squared, our parent function, minus 3. So when I'm subtracting outside the parentheses, like this, there's subtraction outside the parentheses, I'm going to move down. Again, we look at the number. So this subtraction outside the parentheses tells us to go down. The number tells me how many to go down, which is 3. So again, I go to my vertex and I just go down 3. So here we go. 1, 2, 3, dot. 1, 2, 3, dot. 1, 2, 3, dot. Okay. Go up here a little bit more. So we're going to find an intersection. Here we go. 1, 2, 3, dot. 1, 2, 3, dot. And then we just connect the dots. La, 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 la. And there's our parabola. Again, same size parabola. Same shape parabola. The only thing that happened is now he moved down. Alright. So now we're going to talk about another difference that we can make to a function. I'm sorry, to a quadratic. So if we have a quadratic, which is our parent function, and all of a sudden I throw in a negative symbol in the front, okay? When there is a negative symbol in front of the x, okay? That means I'm going to what's called reflect the quadratic, which is another nice way to say flip. So we're going to flip it over the x-axis. So right now we have a positive parabola that's facing up. It looks like a smiley face. We know that the opposite of a smiley face is a frowny face. So we're going to do the opposite. So we're going to put our point at the vertex. If we're at negative 1, 1, the opposite would be down here at negative 1, negative 1. We have a point at 1, 1. The opposite would be 1, negative 1. I have a point here at 2, 4, negative 2, 4. So the opposite would be negative 2, negative 4. Here I have a point at 2, 4. The opposite would be positive 2, negative 4. And then we would just draw our parabola. So we reflected it over this x-axis. A reflection's like a mirror, okay? So it's taking it and flipping it. So when you see a negative outside of the parentheses in the front, that's a reflection. So we're going to flip it. All right, let's do 2 more. All right, now let's talk about a parent function. When I all of a sudden throw a number in front of it. So when I have a number in front of the parentheses, okay? A number in the front of parentheses will do what is called compress. When I compress something, I squeeze it together. So it's another nice way to say that you're going to make the graph fatter, okay? So in this case, we're compressing it by a factor of whatever the number is here. So in this case, the number is 3. So our vertex would stay the same. 1, 1 would now change to 3, 3. Because we're multiplying it by that factor of 3. All right. Negative 1, 1 would now change to negative 3, 3. So as you can see, our graph is now getting wider, fatter. It's like somebody is coming in and pushing it down so it has to space out. Okay, so that's called a compression. So when there's a number in the front, your graph will get fatter. All right. So now let's talk about if there's a number in the front that's not a whole number. Let's say I have a fraction in the front. So when I have a fraction in the front of parentheses, we're not going to compress. We're actually going to stretch. We're going to make it skinnier. It's like when you take something and you pull it apart, it gets skinnier. Okay? So in this case, we're stretching, making skinnier, by a factor of 1/2. Okay? So now when we graph it, if we were at 1, 1, now we know that half of 1, 1 is a half and a half. So here we go. That would be our little points right here. 2, 4 would now go to 1, 2. 2, 4 would now go to 1, 2. So if we look, our graph is now getting, it's going to come to that same vertex right here, but he's still now getting very skinny. Okay? So when we have a fraction and a half, our graph will get skinnier. So let's throw a couple of them in there together. Let's say that I have my parent function and I'm going to change it. Let's say that now I have, I don't know, x, Annabella, give me a number between 1 and 4.
3.
Okay, plus 3. Give me another number between 1 and 4.
2.
Minus 2. Okay, so let's try this. So according to this, I'm going to look right here. Okay, inside means I'm going to the right or the left. If it's adding, I'm going to go to the left. So this right here tells me I'm going left 3. This outside number tells me if I'm going up or down. Because it's subtraction, it's telling me I'm going to go down 2. So I'm going to go to my graph, and according to these directions, I'm going to move my graph left 3, down 2. So here we go. Go to our vertex, left 3, 1, 2, 3, down 2, 1, 2. Dot. Go to this point right here, left 3, 1, 2, 3, down 2, 1, 2. Here we go, another dot. Left 3, 1, 2, 3, down 2, 1, 2. Again, we just kind of trace the line until we find an intersection. There's a point right here. So left 3, 1, 2, 3, down 2, 1, 2. Again, left 3, 1, 2, 3, down 2, 1, 2. Okay, and then we just draw our parabola. So there we go, guys. I hope that helped. I'll make another one for you in a second. Let me know if you need any other help. Say bye.
Bye.